we are live. So dividing radical and rationalizing denominator, that is actually the same thing that we did yesterday. This is really technically just part 2, right?
Part 2.
And it's really not anything new other than practice. We're just practicing them because they tend to be confusing and a little complicated. So I just want you to see lots of examples. Yes?
What can be confusing is when you had like 2 square root of 14 times the square root of 2x.
So when I see this, so this is multiplying, not dividing. But when I look at that, immediately I see 14 as 2 times 7. And immediately, what does that mean? It means 2 times the square root of 2 times 2 times 7x. 2 times 7, I'm just putting the 7 with the x, I'm putting that 2 with the other 2. You see what I'm doing?
Yes.
So my brain is saying, oh, I can immediately take out a 2. You see what I'm saying?
Mm-hmm.
So that's the way I often do it. So that comes out as a 2. So it's 4 square root of 7x. You see what I'm saying?
Yes.
Right? So now, so we're going to just do a bunch of problems. I just want to make sure that okay, good. So 1. So let's say I gave you the square root of 21 over, okay, how do I do this? Yeah, square root of 2. What would I do? Yes, Michael.
Simplify the 21, or not simplify,
Do the thing.
The thing. Whoa.
Whoa, Garen.
Did I do the thing?
Crazy move.
yes.
What was that dance called in Alice in Wonderland?
Okay.
No.
Ah,
Yeah.
so, guys, what is he saying? Remember, if you don't, oh, I don't have it here anymore. Hang on. 4, 9, 16, 25, right? All my perfect squares. If a perfect square does not go into the number, it cannot be simplified. Right? There is no perfect square that goes into 21. So if you change it to the square root of 3 times the square root of 7, you just wasted your time. And my time, I might say. Sorry, okay? I'm sorry. Okay.
You said that.
What is a problem though, Michael, with this problem? There is a rule that says never leave your answer with a radical in the. Okay, so how? Yeah. So what would I do to do that? To solve it? Keep going.
And then we multiply.
It's got to be, but this I've got to multiply it times a 1 or a weird 1. Right? Okay. So right, square root of 2 over square root of 2. So then that gives me, what do I have, Michael, in the numerator? So guys,
You just have 2.
what's 2 times 21?
Oh, I was thinking the denominator. Sorry, 42.
Right? Over 2.
Over 2, yeah.
Okay. Now, am I done? Am I done?
No, you can simplify.
Can you?
And then you get that square root. No, wait, that just.
Is there anything that goes, any perfect square that goes in 42?
No.
I don't think so.
There isn't.
6
Unless
times 7,
suddenly 7 times 7 is
2, 14, 3 times, no, doesn't work. So yeah, that's the answer. You're done, right? Okay, good job. All right, so what if I gave you this? What if I gave you this? The square root of 20 over the square root of 2. All right. Then, what would you do?
Okay. So first you would multiply the numerators. So it would be the square root of 40
Okay.
over 2.
Okay, so that is one way to do it. The only thing is, if you don't reduce when you can reduce, then you're gonna have to reduce later. It's easier to reduce when the numbers are small than when they're big, right?
Yeah.
The question is that,
Well, then
A-
it'll become a 1.
that's an even number, and that's an even number, yeah, right? So I'll first do it your way, right? But then I'm gonna show you the easier way. I think it's easier. So he said immediately, the square root of 2 is the problem. So he then said, okay, square root of 2 times the square root of 2, and then that gave him the square root of 40 over 2, right? But we now have to reduce this, right? So Ben, you see that?
Mm-hmm.
That has,
It would
what's the
be-
square root of 40? That's not
Some
too hard.
Number. Oh, wait. The square
Which,
root of
how
40?
can we simplify it? Look at your perfect squares.
The 4 and 10.
Okay, so we have to simplify it. So this is the key. You have to make sure it's simplified. So that's 4 times 10. The 4 comes out as a 2, right?
Yes.
And this becomes a 2. So we have now 2 square root of 10 over 2. Is that what you said? Can I simplify any further?
Yeah.
What, yes?
Probably,
Yes?
yes.
Probably. He's looking at my face. He's not looking at the board. He's looking at my face. Probably. What's the same upstairs and downstairs?
2.
Oh my gosh!
2.
2 over 2 is 1.
Okay.
So your final answer is
What?
the square root of
No.
10, right? Right?
Yeah.
Alright, so
Okay.
that's way, this was way 1. Way 1,
That took a while.
right? Here's
Yes.
way,
No.
here's way 2.
Oh, ha, ha,
Both-
ha, ha.
Both of the ways are fine, really, quite honestly. There's always more than one way to do things, right? Yes,
I'm looking
Tia.
at
You want to do way 2? Okay, great.
No.
So wait, let me rewrite it. Square root of 20
Way 1.
over the square root of 2. Yes.
You could reduce 20 to 2 squared times.
Oh, actually, no, you could make it 4
Okay.
and 5.
All right.
And then
So
that would make it
yeah.
easier.
So
4
yeah,
and
you
5.
might have done 4 times 5 times 2, right, or something like that.
Yep, yes.
And then right, but you would still get the same answer, right? Now my question though is, what could you do
Oh.
here? What could you do? Miro double E. Okay, but how can I reduce it? It's totally 2 separate square roots.
Actually, Gary, one square root.
Are you guys in the back table listening? 'Cause
Yeah,
I'm
we're
really
listening.
wanting you to see that. All right, so she's saying that I could write this all under 1 square root as 20 over 2. You with me?
I love
Okay,
how she
keep
said
going.
that. Actually,
Keep
Gary,
going,
it's
Mira.
one square
Do you love this second way?
Oh no,
Do you love
I
it?
love how she said that. Well, Gary, it's actually 1 square root. It's like
Right,
Khan Academy.
precisely.
Yeah. Precisely.
Okay, yes.
Processly.
Now we can reduce,
What?
Mira.
Wicca, what?
How? 2 goes into 2 once, right? 2 goes into 20 10 times. So really, what we have is the square root of 10 over 1.
Just the square root of 2.
But the square root of 10 over 1 is the same as the square root of 10. So our final answer is the square root of 10. Notice if I reduce right away, I don't have to reduce later, right? It's not a big deal. They both work. It's just that sometimes, this isn't maybe the best example, but sometimes when you reduce later, you're dealing with big numbers. Like what if you had to reduce 264 and you're thinking, I don't know what goes into 264, right? Wouldn't it be easier to reduce right away
Yes.
and keep the numbers small,
Yes.
and then you don't have to reduce, right?
Yes.
Later, right? So anyways, that's just, okay. Number 3, oh, that was, all right, we're in a lecture. Oh yeah, okay. I remember what I'm doing. 3, okay.
Wait, what are
um,
we doing again? Please tell me everything.
Okay,
You should do that one day. Just be like, suddenly.
what if I
What are
gave
we
you,
doing again?
what if I
Tell me
gave you,
everything I've taught you.
what if I gave you the square root of 15 over 7 square root of 3?
Okay, Gary, I have a question.
Yes.
Is it possible to have a problem where it's like a fraction and it's like the square root of 15 over square or 7 and then the square root of 3 and it's like the big square root sign like. This?
Start over.
Just
My
a
brain
second.
just started fried. Say it again.
Is it possible to do something like that?
Totally. Oh well. Oh no. Oh yeah. It is possible.
With
I,
the 2
but
square
none of
roots?
these. Yeah, it's
All
possible.
beer.
Yeah, but I'm not
All
going to do
beer.
that. I'm not going to do that.
You're
Shame on you for asking such horribly hard questions.
My brain.
Stop asking questions that take carbonate.
I know, it makes it a lot
No,
worse.
great questions. I absolutely love your questions. They're fabulous. Okay, so let's look at this, guys. Everybody, look at this problem. There's different ways to solve this, right? Different ways. Does anybody see a method that they could do?
Oh,
Okay, Anna.
Okay,
Yes.
put it under one big square root sign
Ah,
first.
okay, so we'll put it under one great big square root sign, 15 over 7 square, excuse me, sorry. Oh, that's
Wait.
interesting, wait a minute.
wait,
Oh, that's 7, oh, that's interesting. That 7 has to be on, oh wait, yeah.
what?
The 7 is not under the square root sign, right?
You're making
So
this
I
all
have to
more
keep the
complicated.
7 outside of it, right? So that doesn't look very clean in here, so.
No.
This is the same as 1/7 in front of the square roots, right? So I'm gonna write 1/7 here. Now, under the square root sign though, what am I gonna do, Anna?
Okay, you're going to put a 3. Because,
Oh, right,
yeah.
of course. I'm gonna finish
Okay,
writing the
so-
problem.
Okay, but 15 could be 5 times 3.
Oh, right. So really, you're saying we could, 3 goes into 3 once, 3 goes into 15 5 times, right?
Yes.
Oh, suddenly then, sounds to me like Anna is saying,
It's 5
the square root of 5
is the answer.
over
1.
the 7,
Oh.
right?
Whoop.
Now, why would I put the square root of 5 upstairs and not downstairs?
Because it's on top.
It is on top, and if there is no, right, and if there is no fraction too, the number always belongs to the numerator, right?
Yes.
You guys all know that, right? Okay, good. So good, so that would be the answer. Pretty easy, really,
Yes.
right? Well done, Anna. Okay, how about, can I erase?
Good
So I
job.
can start.
We have 3 minutes, by the way.
Oh.
I have 3 minutes?
Yeah.
Okay, gotta erase a little faster.
Yeah, we need to come
Okay.
on school and bring this up.
Okay, here we go. Now, number 4, am I on 4? Okay, so what if I gave you, the square root of 3 over 10x?
Oh dear.
No,
That's when I knew catchphrase.
I would put them under separate square roots, wouldn't you? Because I can't simplify this way. 3 doesn't go into 10. So I'm going to just do them separate. Square root of 3 over the square root of 10x. Now, what would I do? Yes, Gideon.
You multiply the numerator and the denominator by 10x over 10x, and you do the thing.
Square root of, right.
Or yeah, square root.
Square root of 10x over square root of 10x, because the rule says I can't leave an answer with a radical in the denominator. So therefore, underneath,
the square root
I
of
get
30.
10x. Upstairs, I get the square root of
Okay.
30x. Now I ask myself, does any perfect square go into 30?
Yes. No,
No.
yeah,
No.
no.
5 times 6,
I knew that.
2 times 15. Nope. So that's it. That's my answer.
But wait,
Square root of 30x.
wait. Wouldn't you not want to have 2 x's?
Say what?
Wouldn't you not want to have 2 x's in the equation? Because like say 6, like.
Ah, well, that's a good question. But remember, the square root of x times the square root of x is x, right? So I want this to be exactly what that is, right? All right, so let's try another one, 5. What if I gave you something like this? The square root of 6 over 20x, let me think about this for a second, to the 3rd. Ooh. Right? So, yes, I could reduce right now, couldn't I? I don't want that to be an option. Can I change this 6 to 7?
Yep.
I just want you to see one thing. Sorry, I apologize. So now it's 7 over 20 x to the third.
Okay.
So I'm going to separate them, right? Because there's nothing I can do upstairs and downstairs, right? So I got the square root of 7 over the square root of 20. How would I write my x again? Well, it doesn't matter. I'll just write x cubed. And then I'm going to put an equal sign. I'm going to keep going. I want to simplify. I don't want to multiply top and bottom by 20x to the third.
That'd be
Do you see
hard.
why?
Yeah.
Because I know part of 20 can come out. So if I multiply a number that hasn't been reduced yet and simplified, then I'm dealing with really big numbers later. 7 times 20, I'll have 140. I'm thinking, oh my gosh, right? What goes into that? You know what I mean? So I don't want to do that. So I'm going to simplify first. So let's rewrite this. It's 20 is, perfect square is 4 times 5. And then I've got x squared times x. You guys agree with me?
Yes.
Okay? So now suddenly I've got the square root of 7. The 4 is going to come out as a 2. The x squared is going to come out as an x. So that gives me over 2x square root of 5x. You with me? What's my only problem now? Square root of 5x. That's my only problem. The 2x is fine. Does that make sense? So now I'm going to multiply 7 by 5x instead of by 20x cubed, right?
Yep.
So now I'm just going to quickly do it really fast before we leave.
35
5x over
over
root of 5x.
7x.
So that gives me
It would be 7x, right?
35x over 5x times 2x is, 5 times 2 is 10. X times x is x squared. Right? And then the x, I can bring,
There should be a square root
Over the 35.
over the 35.
oh yeah, you're right. Square root of 35x.
Woo, we're done.
Phew, this is hard work. Okay.
Let's go.
I like doing the things.
Abandoning me.
I like that.
Yes.
Hey, we're